Hello students, this is a video on the topic tests that are available on the Bodhee Prep Android app. Now these tests should be taken once you have completed the basic concepts of a given topic. Once you do that, you can take this test to understand your readiness to apply those concepts that you have learned in a test. Once you give a test, that is when you come onto this video where we give you the solution for every question and an analysis of what you should have attempted and in the kind of time that you should have attempted the questions. There are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So please download the app and make use of these tests. This video is about the topic HCF LCM, and this is the fifth test on this series or on this topic. Overall, the test analysis, if we talk about, the test is a moderate level of difficulty test. 6 questions net correct would be a good attempt. Good meaning 90 to 95 percentile easily in this test can be fetched getting 6 questions net correct. And the ideal time that you should take for this test is about 19 to 22 minutes. This time will include getting the 6 questions correct and also having an attempt at the other question. So it's that is the time for the entire test that you will take, or you should take rather. Looking at the questions, question number 1 says, let n be the least positive integer greater than 1000 for which greatest common divisor HCF of 63 n plus 120 is 21 and the greatest common divisor or HCF of n plus 63 comma 120 is equal to 60. We know that 120 is 60 into 2. So n plus 3 also has to be a number which is 60 into something which is not 2 or a multiple of 2. Now, since a number multiplied by 60 or a multiple of 60 will end in 0. So n plus 63 has to end in 0, which means the value of n has to end in 7. It is a number greater than 1000, so ideally a 4-digit number ending in 7. If we put that here, we can say that the last digit of n plus 120 will be 7 because n ends in 7. And also this has to be a multiple of 21. 63 is 21 into 3. So n plus 120 has to be 21 into something which is not a multiple of 3. Now to take 21 to a 4-digit number greater than 1000, we have to multiply it by around 50. Also, we need the last digit to be 7. So we can multiply it by 57, but 57 and 3 will have 3 common, so not possible. We can look at 21 into 67, 21 into 77, 21 into 87, and so on. 87 again, 28 plus 7 will be 15, 21 into 97, and so on. Suppose we take the value of n plus 120 as 21 into 67. 21 into 67 will be 67 into 20 will be 1340 plus 21 into 7. So this will become, if we just multiply 67 into 21, 67, and this will be 134, and therefore 1407. 1407. If n plus 120 is 1407, this means in this case n will be equal to, let me write this a little neatly so that there is lesser confusion. We are taking n plus 120 as 21 into 67, which gives the value of n plus 120 as 1407. So correspondingly, the value of n will be 1407 minus 120, which will give us the value of n as 1287. And therefore n plus 63, from here I write n plus 63 will be 1287 plus 63. 1287 plus 63 will be 1340 is 1350. Now 1350 has to be a multiple of 60, but if we divide 1350 by 60, 1350 will not be divisible by 60 because 135 is not divisible by 6. So if we divide this, or if we look at the multiple of 60 close to 1320, that will be 60 into 22 is 1320. And therefore there is a remainder of 30 here. So what we do is we then look for the next value, which is 21 into 77. 21 into 77 will increase the value of n plus 120 by 210 because there is an increase of 10 here. So this will become 1617. So the value of n will become 210 increase 1497, and therefore n plus 63 will become 1660. 210 1560. 1560, if you look at 60, 1560 will be divisible by 60. 6 2s are 12, 3 6 26. 60 into 26 is 1560. Now, if we look at these two numbers, 60 into 2 and 60 into 26, there is a 2 common as well. So this will also not satisfy HCF of 60. We'll get the HCF of 120. So what we can do is we can keep increasing this number. If we look at 21 into 87, 87 is divisible by 3, so 3 is common, will not work. 21 into 97. 21 into 97 will increase the value of n plus 120 by 420 because there is an increase of 20 here. 21 into 20 is 420. So 1617 will increase and become 1617 plus 420 will be 2037. 2037. 2037 minus 120, therefore the value of n will be 1917, and therefore n plus 63 will be 1917 plus 63, which is 1980. 1980, if we divide by 60, we will get 33. And therefore we can say if n is equal to 1917, here we get the value of 63 is 21 into 3. At n is equal to 1917, n plus 120 becomes 21 into 97. Clearly the HCF or GCD will be 21. At n is equal to 1917, n plus 63 is 1980, which is 6 into 33. And 120 is 6 into 60. 60 into 33 and 60 into 2. As we can see, the GCD is 60. And therefore, the required value, which is greater than 1000 and the least possible value of n becomes 1917. What is the sum of digits? 1 plus 9 plus 1 plus 7, which is 18, becomes the answer. Again, in terms of level of difficulty, I would say this is a difficult question. 3.5 minutes, easily to solve this question. Suppose ABC are positive integers such that a plus b plus c is 23. GCD of AB plus GCD of BC plus GCD of CA. Greatest common divisor or HCF. The sum is 9. What is the sum of all possible distinct values of a square plus b square plus c square? Now, if you look at a plus b plus c, there are two cases possible. Either the values are odd, odd and odd, or the values are even, even and odd. Now, in the first case, assuming A, B, C are odd, we can say that GCD of AB will be odd because two odd values can only have an odd value common. GCD plus of GCD of BC will also be odd, and GCD of CA will also be odd. Odd plus odd plus odd can give me 9. So there is a possibility here. If you look at the second case, even plus odd, A and B are even numbers. GCD of A and B will be an even number, at least 2. GCD of even and odd has to be odd because one has 2, the other does not have 2, so 2 cannot be common. Similarly, GCD of AC, which will also be odd. Odd plus even will actually give us even, so this cannot be 9. So the second case is not possible. The only possibility is that all the three numbers are actually odd. If we look at the other cases, that is even plus odd, this will be an even sum, so cannot be 23. Even plus even cannot be 23, so not possible. Only possibility that we have is that all the numbers are odd. Now, the greatest common divisor that we can have when there are three values which add up to 9, since this is not a possibility, I'm removing this. We look at only odd plus odd numbers, GCDs. It cannot be 9, because if this is 9, then the rest have to be 0, 0, which is not possible. This is odd, not 0. And therefore, I'll check with 7. If the GCD of CNA is 7, the other two values have to be 1 and 1 for sure, because that is the only way to reach a total of 9. Now, GCD of CNA is 7. We can have the numbers as 7, 7. This is C, this is A. 7, 7, 7 plus 7, 14. So B becomes 14 and 9, 23. As we can see, the GCD of CNA will be 7, CNB will be 1, and A and B will also be 1. So this case is possible where A, B, C are 7, 9, and 7. The order will not matter because in the end we have to just square the 3 and add. So order of ABC will not matter. With GCD 7, the next possibility is I have one of the numbers is 7, the other is 14. But that is not possible because all the numbers have to be odd in my case. The third possibility is one of the numbers is 7, the other number is 21. In this case, the sum of the numbers will exceed 23. So with GCD 7, only one case is possible, which is 7, 7, 9. The next odd number possible for GCD is 5. If one number is, if one of the term is 5, and we have to add two other odd terms to it to make it 9, the only possibility is 5 plus 3 plus 1. 5 plus 2 plus 2 is not possible because we need odd numbers. And therefore, we can say with this CAB, the GCD of CNA is 5. So we put 5, 5, 5 plus 5 is 10. Again, this is 13, will not get 23. Also, we need the GCD of BC to be 3. So C has to be a multiple of 5 as well as 3. So we put C as 15. With A, we put 5. So the GCD of C and A will become 5. B, we put 3. GCD of C and B will be 3. 5 plus 3 is actually 23. So this value is also satisfied. Second option becomes 15, 5, and 3. This is the only possibility with GCD 5. 5 and 10 is not possible. 5 and 15 is done. 5 and 5 is not giving us the rest of the numbers. If we put further reduce GCD to 3, we will have 3, 3 and 3. That is the only case that is left. But if the GCD is 3, 3, 3, all the numbers have to be 3, which will not add up to 9. So this case is also not there. So we are getting two cases. In the first case, A square plus B square plus C square will be 7 square plus 7 square plus 9 square, 49, 49, 98, 98 plus 81. Sorry, is 187. 187. Next is 15 square plus 5 square plus 3 square. 225 plus 25. 250 plus 9. 259. So this will become 49 plus 81. 98 plus 81 is 179, not 187. Now it is okay. 9, 9, 18, 8 carry forward 1, 12, 13, 3, 1, 4. And therefore the required sum becomes sum of all possible distinct values of A square, B square, C square becomes 438 is the answer. Again, for me, this is a difficult question. 3.5 minutes easily to solve this question. How many ordered pairs AB of positive integers satisfy the equation AB plus 63 plus 20 into LCM of AB plus 12 into GCD, greatest common divisor, or HCF? GCD denotes the greatest common divisor. LCM denotes the least common multiple. Now, suppose A is a number of the form HX, B is a number of the form HY, where X and Y are co-prime. Therefore, we can say that GCD of AB will be nothing but H, and therefore LCM of A comma B would be, take the HCF common H, the remaining part is X and Y. So this equation can be rewritten as AB is H X into HY plus 63 is equal to 20 into LCM HXY plus 12 into H. Taking the H terms on one side, 63 becomes, this will be 20 HXY plus 12H minus H square XY, and therefore 63 can be written as, taking H common, 20 XY plus 12 minus HXY. Now, H has to be a factor of 63 only, then it will divide and everything will remain integral. The factors of 63 are, 63 is 9 into 7 or 3 squared into 7. So 6 factors are there. The factors are 1, 3, 7, 9, 21 and 63. What we'll do is we'll take H to be one of these values one by one. If H is equal to 1, we can write 63 will remain 63. It is equal to 20xy minus xy. 20xy plus 12 minus xy, which means 63 minus 21, which is 51, is equal to 19xy. Clearly, xy will be 51 by 19, which is fractional. So this is not true. If h is equal to 3, 63 by 3, we can write 21 is equal to 20xy plus 12 minus 3xy, which means 21 minus 12. 9 is equal to 20 minus 3, 17xy. So xy, the product of these two numbers should be an integral, positive integral, 19 by 7. So this is also not possible. H is equal to 7 means 63 by 7. 9 is equal to 20xy plus 12 minus 7xy. This will give us a negative value. 9 minus 12 is minus 3. 20xy minus 7xy is 13xy. Xy is negative, not possible. If h is equal to 9, 63 by 9 is 7 is equal to 20xy plus 12 minus 9xy. Again, the same problem. 7 minus 12 is minus 5 is equal to 11xy. Xy negative, not possible. H is equal to 21. 63 by 21 is 3 is equal to 20xy plus 12 minus 21xy, putting the value of h. So this means 3 minus 12 minus 9 is equal to 20xy minus xy, which means xy is equal to 9. So this is a possibility. In this case, since xy is equal to 9, x could be 1, y could be 9. Are we looking at ordered pairs? Or x could be 9, y could be 1. 3 and 3 is not possible because x and y have to be co-prime. So we get two pairs from here. This is okay. If h is equal to 63, 63 by 63 is 1. So we write 1 is equal to 20xy plus 12 minus 63xy, which will give us 1 minus 11 is equal to minus 43xy. Again, xy comes out to 11 by 43, which is not possible. And therefore, this is also not possible. So the only possibility that we have is when h is 21, the numbers will be a could be 21, b could be 21 into 9, or vice versa. B could be 21 into 9, a could be 21 into 9, and b could be 21. So how many ordered pairs are there? 2 ordered pairs are possible, and that becomes our answer. Again, in terms of level of difficulty, I'd say an outright difficult question. 3.5 minutes at least to solve the question. Suppose ABC are positive integers such that a by 14 plus b by 15 is c by 210. What is the following statements is true? So we can just simplify this. Taking LCM 15a plus 14b, upon LCM of 14 and 15 is 210. 14 into 15, so 15a. 15 into 14, so 14b is equal to c by 210. So essentially the equation that we have is 15a plus 14b is equal to c by 210. We have to check which of the following is true, 1, 2 and 3. 210 cancels out, is equal to c is what we will get. Now option or the statement 1. If GCD of a and 14 is 1. So suppose a is not a factor of 14, so a does not have 2 or 7 in it. Or GCD of b is 1 or both, then GCD of c and 210 has to be 1. Again, if we put b as 3 here and give a any value, say 9, 11, what will happen is 15 into a will be a multiple of 3. Because b is 3, 14 into b will be a multiple of 3. Therefore, c will also be a multiple of 3. Since c is a multiple of 3, GCD of c and 210, since c is a multiple of 3, 210 is a multiple of 3, will be 3. So this does not have to be true. By simply putting a as 3, b as 3, I am able to prove that this is not always true, and hence 1 is not always true. Second information or second point, if GCD of C and 210 is 1, so 210 essentially is 2 into 3 into 5 into 7. 5 twos are 10, 7 threes are 21, or 7 twos are 14, 5 threes are 15. If GCD of C and 210 is 1, that means C does not have 2 or 3 or 5 or 7 or multiples thereof. Then GCD of A and 14 has to be 1. Now, since C is not a multiple of 2, 3, 5 or 7, we know that 15A is a multiple of 3. That means 14B cannot be a multiple of 3. 15A is a multiple of 5, so 14B cannot be a multiple of 5, which means B cannot be a multiple of 3 or 5. And therefore, GCD of 15 and B has to be 1. Similarly, if I look at this, if since C is not a multiple of 5 and 7, and 14B is a multiple of 2 and 7, sorry. C is not a multiple of 2 and 7, 14B is, therefore 15A should not be a multiple of 2 or 7, which means A should not be a multiple of 2 or 7. Therefore, GCD of A and 14 will also be 1. Therefore, 2 is true. GCD of C and 120 is 1 if and only if, again, if you look at the third statement, 15A, since 1 is false and 2 is true, by default we get option D as the answer. But if we do solve it further, 15A plus 14B is equal to C. If A and 14 do not have nothing in common, then A will not be a multiple of 2 or 7 if both. If B and 15 have a GCD of 1, B will not be a multiple of 3 or 5. And therefore, we can say this entire thing will not be a multiple of 3 or 5 because this term is not a multiple of 3 and 5. This entire sum will not be a multiple of 2 and 7 because this term is not a multiple of 7. So this entire term will not be a multiple of 2, 3, 5, 7, which means C will not be a multiple of 2, 3, 5, 7. Since C is not a multiple of 2, 3, 5 or 7, GCD of C and 210, which comprises of only 2, 3, 5, 7 will be 1. Hence 3 is also true. Putting values and trying to prove false is also a good approach for this question. But in terms of level of difficulty, I would say this is still a moderate to difficult level question, and 2 to 2.5 minutes would be required to solve this question. Let m be the least common multiple of all integers 10 through 30. 10 through 30. LCM of all integers 10 to 30 is m. Include. Let n be the least common multiple of m. So LCM of m 32, 33, 34, 35, 36, 37, 38, 39, and 40. This is n. We have to find n upon m. If we find out the LCM of this, clearly m will be a large number, so m has to be included. If we look at 36, now when we are finding out the LCM of or the value of m, between 10 and 30, there is a term 16, so that will be included. And there is a term 18 as well. 2 from this, sorry, the highest term that is included is 16. We require 32. There is no other term which has a power of 2 higher than 16. So I'll have to multiply m by 2. 32 is taken care of. For 33, 11 has been included here. And definitely one of the 3's will be there. Nothing to be done. For 34, 17 has been included here and definitely 2 is there. Nothing to be done. 35. Clearly, there will be a multiple of 7 and a multiple of 5 between 10 and 30. Multiple of 10 itself is 5. Multiple of 7 could be 14. So 5 and 7, 35 is also been included. 36, 36 is 2 into 18. 18 has been included. And in 16, there will be an extra 2 as well. So 36 has been included. 37 is a prime which does not lie between 10 and 30. So 37 has to be included. 38. 38 is done because 19 is there, 2 is there between 10 and 30. 39 is 13 into 3. Between 10 and 30, there is 13 and definitely a 3 as well. 40, 40 is 20 into 2 or 4 into 5. There is definitely a multiple of 4 and 5 between 10 and 30, so that has been included as well. So we can say m into 74 is equal to n, which means n upon m is simply 74. The LCM changes at a power of the prime or at prime numbers. So LCM will change at 32 because it is a power of 2. So it gets multiplied by 2 and then it changes 37, which is a prime number. So we can directly write n is equal to m into 74. Again, I'd say this is a easy to moderate level of difficulty question. Basic understanding of LCM will help you solve this. And we've done this in class as well, or similar questions in class as well. I think 90 seconds should be good enough to answer this question. The least common multiple LCM of A and B is 12. Least common multiple of B and C is 15. B is common in both of them. 12 is nothing but 4 into 3. 15 is nothing but 3 into 5. So if I do assign values, I can say B is equal to 3, which means A could be 4. Here, continued B is equal to 3, so C could be 5. What is the least possible value of the least common multiple of A and C? In this case, LCM of A and C would be LCM of 4 and 5, which is 4 into 5 or 20. What is the least possible value? And that itself becomes the answer, because if I had to increase the number, increase the value, then we could have taken A as, instead of 4, 4 into 3 itself, B as 5 into 3 and worked from there. But since we are looking for small values, we look at the minimum possible value that can be there in A and B. B cannot be a multiple of 2, otherwise we'll have to have a 2 here. B cannot be a multiple of 5, otherwise we'll have to have a 5 here in the LCM. So the only term that is common is 3. The remaining terms could be A and B in the smallest form. LCM of A and C smallest value is 20. Again, I think a easy to moderate question, 1.5 minutes should be good enough to answer the question. What is the ratio of the least common multiple LCM of 180 and 594 to the greatest common factor, or HCF, of 180 and 594? Now we know that LCM into HCF is equal to, we'll have to find the HCF. Let's not use this. Let's just put the values. 180 and 594. 180 is 80 into 10. 594 is equal to 18. 3 is a 54. 33. 10 and 33 have nothing in common. So the HCF becomes 18. LCM will be 18 into 10 into 33. HCF will be 18 and therefore the ratio will simply be 330. Again, one of the simple questions of the exercise. 60 seconds, good enough to do this question. Let S be the set of the 2005 smallest positive multiples of 4. Multiples of 4 smallest. So 4 into 1, 4 into 2, 4 into 3 and so on till 4 into 2005. So the smallest number is 4. The largest will be 4 2s are 8. 8020. 2005 into 4. This is S. T be the set of 2005 smallest positive multiples of 6. The smallest term is 6 ones are 6, 6 twos are 12, and so on. Goes up to 6 into 2005, which will be 12030. 12030. How many elements are common to S and T? The common terms will be the terms that are multiple of both 4 and 6. Therefore, we look at LCM of 4 and 6, which is 12. The common terms will be multiples of 12. Smallest being 12 into 1, then 12 into 2, and so on. Clearly, the limiting value we will get in S because T has more numbers. Therefore, beyond the limit of S, the numbers in T do not have to be looked at. So we simply see the multiples of 12 that are less than 8020. 6 are 72 minus 82. 6 are 72 minus 100. 8020. 8s are 96. So the division can happen 668 times. The smallest number is 12 into 1. The largest will be 12 into 668, which will be 96. 4 short of 8020, so 8016. So how many numbers are common? From 12 into 1 to 12 into 668, 668 numbers are common. Again, I think this was also one of the easier questions among in the set. 90 seconds, tops 2 minutes should be good enough to answer this question. For how many values of k is 12 raised to power 12? 12 raised to power 12 is 4 into 3 raised to power 12, which is 2 raised to power 2 into 3 raised to power 12, which is 2 raised to power 24 into 3 raised to power 12. 6 raised to power 6 is nothing but 2 into 3 raised to power 6. So 2 raised to power 6, 3 raised to power 6. 8 raised to power 8 is 2 cube raised to power 8, which is 2 raised to power 24. We have to find the value of k. Now, the LCM of these three numbers has to be this value. So if you look at the power of 2, that k can have, we look at the highest power of 2 amongst the three numbers. Here it is 2 raised to power 6. Here it is 2 raised to power 22, which is the same as the one in the LCM. So k can have power of 2 as any number it wants from 0 to 24. Because the highest power we already have. K can be less than this, equal to this, does not matter. So there are 25 options. What about powers of 3? The power of 3 that we have is 3 raised to power 6, but we need the power to be 3 raised to power 12. So k has to have the highest power because no other number has it. So the power of 3 in k has to be 2012, has to be 12, 3 raised to power 12, and therefore the only option for 3, power of 3 is 1. So this is the only option. So the number of values possible is 25 into 1, which is 25. Again, at best a moderate question. If you've done concepts or have been doing the test regularly as well, by now you would realize such type of questions where we have an LCM and we are finding the numbers which can have a given LCM. This is the method, and it can be replicated without too much of a trouble. So moderate level of difficulty, but should be done little quickly because there is just one calculation that has to happen. Rajesh is 150 gold coins, 180 silver coins, 420 platinum coins. He wants to place all the coins in stack so that each stack has the same number of coins of the same type. What is the minimum number of stacks of coins that he can make? Each stack has to have the maximum number. The number has to be same number of coins of the same type. So number of coins in a stack has to be such that it divides all of these three numbers, and it has to be the largest to reduce the number of stacks. We look at the HCF of 150, 180, and 420. This is 30 into 5, 30 into 6, and 30 into 14. If we say that the number of stacks has to be minimum, the number of coins in each stack has to be maximum, and that maximum number will be 30. So if we have 30 coins in a stack, coins per stack, what is the minimum number of stacks that he can make? Therefore, number of stacks will be 150 coins distributed in stacks of 30 will be 150 by 30, which is 5. 180 coins distributed in stacks of 30 will be 180 by 30, which is 6. And 420 coins distributed in stacks of 30 will be 420 by 30, which is 14. And the total number of stacks will be 14 plus 6, which is 25. And that becomes my answer. Again, this is one of the most basic applications of HCF. So an easy question to be done within a minute because the numbers are also pretty straightforward. So if you look at the overall test, as I said initially, the overall level of difficulty will be moderate. But see, this test was clearly divided into two parts. One where the questions were pretty difficult and attempting them might be a challenge. Then there were questions which are pretty simple, right? So, so finding those 6 questions may not be very difficult. If I had to find my 6 questions, they would be 5, 6, 7, 8, 9, 10. So leaving the first 4 questions, which I would not have attempted this, question requires time. I thought this was also difficult because starting to count the cases or the starting point was a little difficult to understand. Would not have attempted this either. There were a lot of cases, the cases that had to be checked for. This, I think, also for me was a little tricky. Beyond this, I was looking at the 6 questions. This is the basic question of change of LCM. Very small numbers, therefore, could have been done. This again was one of the easiest questions in the set. These type of questions have been repeated. We have by now done this type of question as well. Therefore, since I've done it earlier, I'll do it again in the test. And this was, I think, one of the easiest questions of HCF. So my 6 attempts here will be 5, 6, 7, 8, 9, and 10.